Right. Now, today our plan is doing Lewis structures and associated things. Right. So, okay. Okay. Now, you guys give a try for these questions. Okay. Not everything. These things. This first one, second one, third one, fourth one, fifth one, and sixth one. Yeah, seventh one. You can answer up to seventh one. Okay. Up to the seventh one, you can answer. In 5 minutes, try to answer this. Okay. And also after completing this, uh, if you are done with this part, sorry, if you are done with this part, then go for this one. Okay. If you have this paper, you can take the 2024 paper, and you can fill these things too. You guys, yeah, in the 2024 paper, right? The 2024 paper, the first structured essay. Now 27 people can't do the eighth one, except that you can answer everything other than that. Okay, are you done with this question? We're online. Completed?
Yes, sir.
Full. You did the complete structure, is it?
No, sir. A part and the B part. I don't have the paper. I only have until 23.
I have asked to upload that in the group. No, you didn't get that.
No, sir.
Check. You would have got in the group. I told to upload it. Is it there? Isn't it there?
Yeah, sir. It's there.
Mm-mm.
My phone got stuck. It seems.
You can, in case if a student, if you don't have the 24 paper, you'd have got it in the group. I can complete using that. So stay. We will discuss this now. There's a small problem here with some physical students. They are facing some issues. Okay, let's see. Right. Okay. Now let's discuss this and maintain a separate book for this, a CR book. Uh, okay. Okay. But sharply at least, again, no need to come too early. By 3:25 at least come here. No point of coming too early. 3:25 Mario Akule. You guys try to be here. Still raining outside. Kaatha mattuma. Right. Anyhow. Now the first thing is see these questions. See these questions. The question is the first one. No, no. Structured first one. Okay. Right. 2024. First question is particles. Right. Particles in both cathode rays and beta rays have the same charge to mass ratio. What can you tell about that? True or false? That is true. Why? Because cathode ray and beta rays and cathode rays both are what? Electrons. Both are electrons. Cathode ray being also electron, beta rays also is consist of electrons, right? Therefore, cathode ray or beta ray both are negatively charged electrons, right? Therefore, that is true. First answer is true. And you have to write true key and okay, but you have to write a explanation for that. Okay, both are electrons scale. Both are electrons. Therefore, EM ratio is same. Okay, cathode ray give beta ray give both are electrons. Second thing they have asked, in a copper atom, there are 6 electrons having magnetic quantum number Ml equal -1. Hare. When you write copper, how you write the copper's electronic configuration? Copper is 29. So how you write copper's electronic configuration? You write 1s2, 2s2, 2p6, 3s2, 3s2, 3p6, 3d and 4s, 4s1, 3d10. Copper is having a special type of configuration. Normally copper should come as 4s2, 3d9, but it came as 4s1 3d10 because of the special electronic configuration. Can you remember the people who are having special electronic configuration? The numbers. These are the people who are having special configuration 24, 29. Okay, you can check the periodic table. You can check a periodic table. So 24 and 29th element having same electronic configuration. And also 41 to 41 to 47 except 43. All these people are having electronic configuration. It means 41, 42, 44, 45, 46, 47. So if they have special electronic configuration, what should you do? Special electronic configuration mean you have to take one electron from Sn, you have to give for the D. HRI you have to do. But only in palladium out of these people, only in palladium, which is the 46th element, only in palladium what you do, okay, you have to take uh, 2 electrons from D and give to 2 electrons from Sn, you have to give to D. Only in palladium you have to take 2 electrons. Other than that, everyone you have to take only 1 electron and give to D. Okay, right. Write the necessary things. No, wait. Still, but they didn't ask this one. Now Ml -1 they asking. So in quantum numbers, you know there are 4 quantum numbers. No? What are the 4 quantum numbers, children? No, now you just don't look at the book. Just try to answer. What are the 4 quantum numbers? There are the 4 quantum numbers of element is N, L, Ml, and Ms. N says what? It says the energy level. That is known as what quantum number? Principal quantum number. What does L says? Yeah, no. L actually says the shape of the orbital. L mean shape of the orbital. It mean L0 now. What is the shape? S. L1 now. P. L2 num D. L3 num F. They say the shape of the orbital. ML says the orientation of the orbital. Okay, orientation of the orbital. So ML0 nang there is only one room. P nang there are three rooms, 0, -1 and +1. Okay, likewise, if it D 0, +1, +2, -1, -2. There are five rooms like this. Okay, if MS nang the spin. If it rotating clockwise nang we say plus half. If it rotating anti-clockwise nang we say minus half. That is only MS eකට we are telling. So now this is the quantum number. Now they have asked in this question, uh, there are 6 electrons having magnetic quantum number ml -1. Now can ml කියන්නේ ml එකේ -1 නම් can s block s orbitals can they have -1 mls? Can't. They have only what mls? 0. කියන්නේ s block එකක් having only 0. Okay, they don't have -1 කියලා room එකක් ඒගොල්ලන්ට නැහැ. They don't have a room called -1. Only PDF are having -1 rooms. හරි. Can this S have ml -1? Can't. Can this S have ml -1? Can't. Can this P have ml -1 room? Yes. එතකොට 2p6 mean this all the things are occupied. No? All these things are occupied. Again, how many electrons are in ml -1 here? This is a -1 room. How many electrons are here in this? Two electrons are there. In this now, you can write two electrons are in this room. This S do they have? No. This P do they have? Yes. This P also they are having three rooms. No. In this is -1 room. They have two electrons. Suddenly color change. No. Still black color. I see a color change. Can this D have P rooms? D block having P rooms. D block having -1 rooms? Yes. This so D block also will have -1 room. Now, which one is the -1 room? Here. This one is the -1 room. So how many electrons are here? Here also? Two electrons. Why this 3D? 10. So all are completed. So altogether, how many ml -1 electrons are there? 2, 4, 6. Then that statement is true. Sorry. Now Putha write everything, whatever related to this. Put number 2 and write principal quantum numbers. Write, please write it. Okay. Write every single thing. Okay. N mean write principal quantum number. L mean write azimuthal quantum number. So here it says the shell. This one says the shape. This one tells the orientation. This one tells the spin. Okay. ඊට පස්සේ you tell special electronic configuration people කියලා you write these numbers 24 and 29 then 41 to 47 except 43 හරි මේ ටික ඔක්කොම ටික උතන include කරගන්න you write point by point එතකොට these things will go to your head එහෙම තමයි we have to recall the old memories now when I'm telling these things again I full fresh වුණා වගේ oh, everything was like down the pallam right now only we are taking to up the pallam හරි But it's working. Here it's working. Here it struck me. Right. Don't know why. I think this get pressed. This button get pressed. That's the thing. Okay. Now happy? Right. Podaka inconvenient no, when I get stuck there for you guys. Okay. Alright. Then the next question. Um, the F2 ClO plus ion has a trigonal planar shape. F2 ClO plus ion has a trigonal planar shape. Now we'll draw the F2 ClO plus. Puta, now this is a person who is in group 17. Puta, write every single thing, even quantum numbers, ඔක්කොම දාගෙන ලස්සන්ට you did you write everything neatly? Right. Now we'll see the Lewis structure of F2ClO plus ion. Puta, what you have to do normally F2ClO plus mean. Okay, F2ClO plus mean. We have to decide the central ion. Who is the central atom? We have to decide. No? Now all are halogens. All are halogens. Let me. This halogen, this what we call for group 16 people? The name of group 16 people, can you remember? Who can remember group 16 people's name? Online people, can anyone remember? You know, you can answer. Halides mean group 17, halogens. Halides mean after bonding, the ions of halogens is halides. Chalcogons, not in your dictionary. Chalcogons, Chalcogens, chalcogons. That is the name of the group 16 people, chalcogons. Are group 6, no need to write. If whatever the words you have forgotten, I learn. Group 16 people is chalcogons. Again, oxygen is a chalcogen, fluorine and chlorine are halogens here. CHA, CHAl, COGNS, chalcogons. Chalcogons. Sorry. So, in the chalcogons, F2ClO plus is a, now it's a molecule. So, what should you do? You have to see who is the central person. Who is the central person in F2ClO plus? No, chlorine. Out of these people, you see the least electronegative person. Out of these people, who is least electronegative? Chlorine. Therefore, put the chlorine as a central atom. We are deciding. So, now chlorine belong to a third period. If you want to create a Lewis structure for third period person, mean children, what should you do? You have to attach these people according to their valency. Fluorine, what is the valency? 1. So, we have to connect two fluorines now like this. So, I have to connect two F like this. Okay. And this oxygen is connected, definitely should connect with how many bonds? Double bond, because oxygen valence is 2. So put 2 bonds for this one. Now around this one, how many electrons it should have? 1, 2, 3, 4. No, around chlorine. Chlorine belong to 17 group. No? Therefore, chlorine should have 7 electrons. No? So 1, 2, 3, 4, 5, 6, 7 electrons. Now 7 electrons are like this. Okay. Now they are having a plus charge. No? Then this plus charge should come for whom? Normally, this whatever the charge here will come for the central atom. Whoever central, they only get the charge. Then chlorine will get the plus charge. When chlorine get the plus charge, what will happen to this electron? This electron will go away and only this plus charge will come for chlorine. Then finally, this is the F2ClO plus ion. So what is the shape of this? What is the shape? Uh, yeah. How you get this then? How you get this? You get this from tetrahedral. Again, you have to see the first of all electron pair geometry. Now, electron pair geometry mean lone pairs and the sigma bonds. So, three sigma bonds and one lone pair mean altogether there are four VS EPR units. Okay, four VS EPR units mean what is the shape of that? Tetrahedral. From tetrahedral, what they will do? Tetrahedral is this shape, no? So from tetrahedral, what they will do? They will remove one. When they remove one from like this, what is the shape of this? Yeah, this is just pyramidal. Okay, trigonal pyramidal. නැත්තම් නිකම් pyramidal කිව්වත් okay. This is a pyramidal shape. Therefore, actually, how it should come, how you should draw this. You have to put the chlorine in the middle, and you have to put fluorine, and oxygen, and two electrons like this. What is the angle here? What is the angle here? Angle degree? Can't remember? Normally tetrahedral mean what is the angle?
107.5.
Very good. What is the tetrahedral mean? What is the degree? 109 or 109.5? 109 also correct. 109.5 also correct. Then this should be how much? 107. Why? Because of this one electron, 1 degree will reduce. So this is 109 mean this will be 107 degrees. Do you understand this? 100% clear? Shupiri? Right? Okay. Then write the necessary things here. So what is the question now? Question is, okay, the F2ClO plus ion has a trigonal planar shape, that is false. Okay, so you write everything related to F2ClO plus ion. Okay, false, under false, you can see the angle, everything. And you can say electron pair geometry of this is what? What is the electron pair geometry of this? Tetrahedral. What is the shape? Pyramidal. Now, whenever you are doing questions only, you can understand. I have forgotten everything again. No, you can realize, no, have forgotten everything. Okay, that's why this is very important. හරිද? 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 Because first structure essay is from normal unit 1, unit 2. Okay, unit 1, unit 2. ඒකේ mixed එකක් තමයි normally you get this one. හරි. Next one, children. Sulfur has the lowest first ionization energy among the elements fluorine, sulfur, and chlorine. You know why they have asked. Okay. Now you know the first ionization graph. No? You know the first ionization graph. Now in the first ionization graph, according to the first ionization graph, is it true? How? Because how you draw the first ionization graph? Now, what are the things they have given? Fluorine, sulfur, and chlorine. Now, this fluorine killer will take. This fluorine, and this only will be neon. Then sodium, magnesium, aluminium, phosphorus, sulfur, chlorine, argon. So fluorine is the top. Then chlorine, then sulfur. So first ionization they have asked. First ionization, sulfur here, then chlorine, then fluorine. FCl, F when first ionization. Have they given like this? They have given lowest first ionization among the elements. Fluorine, sulfur has the lowest ionization. That is true. Okay, you have to draw this and show that. Putha, who is more, fluorine or argon? Who should be more? Who should be more first ionization? Fluorine or argon? Fluorine. Fluorine only should be more. Fluorine is more than argon. Okay, good. Which one? Yeah, yeah, exactly. From S block you get the structure disease. The third structure disease. Sorry, second structure disease from S block. Okay, they will, you know what they will give? They will tell mainly about, they will give you about ammonia now. Mm. Yeah, the what are we doing is structure disease only. Right. Shape ne? Right. Now, next one, number 5. Okay. Number 5, what they have told us? Rules related to polarizing power of cations and polarizability of anions predict the melting point of lithium chloride is higher than that of potassium fluoride. Hare. So the how you see ionic, it means lithium chloride, melting point of lithium chloride is higher than potassium fluoride. Now we'll compare lithium chloride and potassium fluoride. Okay, lithium chloride and potassium fluoride. Lithium chloride and potassium fluoride. Hare. Now see this part. Lithium chloride and potassium fluoride. Now when you have lithium chloride and potassium fluoride, when you are going down the group, what will happen? Lithium is like this, potassium is like this. Lithium plus K plus. Out of lithium plus and K plus, whose pole for cations what we speak? For cations we speak what? We speak polarizing power. Polarizability is speaking for anions. So polarizing power is high in whom? Polarized power is high in
lithium.
short, short high charge. Yes, lithium. Short high charge. Again a quarter rich boy. Polarizing power is high in short high charge. Short high charge is whom? Lithium or potassium? Okay, according to this, lithium plus only polarizing power is high. For anions, what we speak? For anions, we speak polarizability. We speak about the polarizability. So polarizability is high in whom? Polarizability is high in, okay? Polarizability we are talking for anions, not for lithium or potassium. Okay, now polarizability, so lithium, chloride and fluoride. So Cl minus ion is here. Cl minus are large. F minus ions are small. Okay, so polarizability is high in whom? High in Thadi, large high charge, large high charge. Thadi rich girl. Okay, I said polarizability we are speaking for anions. So that is high in large high charge people. Large mean who? Thadi rich girl is who? Cl minus. Cl minus. Then Cl minus mean. Then what is this Cl minus now? Now what will happen? Now polarizing power. Polarizing power of whom? Polarizing power of lithium is more. Polarizability of chlorine is more. So lithium chloride compound, it is more ionic or less ionic than potassium fluoride. When the polarizing power and polarizability increases, what will happen? Ionic character increases or reduces?
Ionic method
Ionic character
decreases.
decreases. Ionic character decreases. Why ionic character should decrease? Because polarizability and polarizing power, because of this, what will happen? The anion shape will distort. Again, distort කියන්නේ there is a globular shape again. They will break and they will come like some බිත්තරයක් වගේ they will become. So when their globular shape is reducing, what will happen? They are power. Their power will reduce. Hurry. Think what they have told no? They have told the rules related to polarizing point cations and polarizing to anions predict the melting point of lithium chloride is higher than potassium fluoride. That should be false. Why false? Why false? Because here, whose energy is more? Whose ionic character is more? Potassium fluoride. Okay, the lithium chloride's ionic character is less. Okay, here lithium chloride, because polarizing power and polarizability is high in isa, lithium chloride ionic character is less more than potassium fluoride. So potassium fluoride ionic character more mean, the ionic character more mean, to break that also you have to give more energy. Okay. Okay, so melting point mean what? You have to break the bonds. No? So a more ionic compound, melting point, boiling point is more. හරි. මේ ඔක්කොම ටික දාගන්න ලස්සනට. Yeah. Polarizing power increases, ionic character decreases, polarizability increases also, ionic character decreases. Okay. Because of polarizing power, what will happen? The quarter H boy, what will happen? It will try to hang on with everyone. Think what will happen to the respect of the family? They are going to lose the respect of the family because quarter rich boy, he attracts everyone. He attract 30 rich girl, quarter rich girl, he try to attract. හරි. එතකොට but therefore when the polarizing power becomes mean they distort the anion. They attract the anion towards them. එතකොට what will happen? The family's respect goes down. ඒ නිසා උන්ගේ මොකද්ද? Ionic character එක they are losing. Polarizability and polarizing power දෙකම bad thing for ionic character. Those both are bad characters. We are talking about bad character people here. Got the point. Okay. Next, they have said rules related to I go again. In nitrous acid, HNO2, the two NO bonds are equal in length. Huh? Everyone try to draw the HNO2 molecule first. You have to try to draw the HNO2 molecule. Now draw will HNO2. We'll see how you are going to draw the HNO2 now. Everyone try to do the HNO2. When you compare lithium and potassium, lithium's polarizing power is more, quarter each boy. When you take fluorine and chlorine, whose polarizing power, polarizability is more? Chlorine. Therefore, this person's polarizing power is more, this person's polarizability is more. Mean lithium chloride කියන compound එක what will happen? Their ionic character will reduce than potassium fluoride. Okay, Tagal, everyone try to draw the HNO2 molecule. HNO2 molecule. Everyone try to draw the HNO2 molecule. Try to draw the HNO2 molecule. Done? Under HNO2 molecule, wait, under HNO2 molecule, it should come like this. Okay. First of all, you have to draw the NO2 minus. Because NO2 minus only become HNO2. Okay, normally if they ask you to do acid, oxo acid. Huh? Oxo acid. What is it? What is oxo acid? Acid with oxygen. Right? Oxo anion is connected with a hydrogen, you get a oxo acid. Oxo anion means anion with a oxygen. Right? That is oxo anion. Anion with oxygen. Oxo anion. Right? Now NO2 minus, is it oxo anion? PO4 3 minus, is it oxo anion? Okay. HS minus, is it oxo anion? HS minus, is it oxo anion? Tell will you? No bang, no oxygen ne bang. මොකටද ඉතින් මොකද හිතන්නේ ආයේ? Oxygen, if it there only you have, it is oxyanion. How to do this oxyanion now? Now nitrogen will connect here. O2 minus no. How to do now O2 minus? You get a double bond. How you draw this? Now you have to connect first. If there is minus, this minus should come to oxygen. Then connect one oxygen with a minus charge. Again, what do you mean by minus charge on oxygen mean? It will connect only with one bond. Because how they get a charge? They get a charge. If they are connected with equal to their valency number, they won't get a charge. If it less or more, they get a charge. Now normally oxygen valency is what? 2. So if oxygen connect with one bond, it means their one bond is missing. A missing කියන එක තමයි is writing minus. One bond is missing. If I draw 3 bonds like this, what should I put here? I have to put a plus charge. Why? One bond extra කියලා. Huh? Can. When if necessary, we can put. Now we can put it here. After normally, if you put a 3 bond here, it become plus. Okay, right. Now connect one with a minus. After that, the other oxygen should connect equal to the valency number. Then this is only NO2 minus. Now HNO2 what should I do? How should I draw the HNO2 now? First draw the NO2 minus. After that come to HNO2. Then how can you draw the HNO2? Normally hydrogen will connect to this. This is H plus. H plus should come and connect to this O minus. Either what is the HNO2 structure? NO2 minus is this, no? So H will come and connect to this one, right? So this is the thing of HNO2. Alright. So first of all, what should you do? You have to draw the NO2 minus. After that, you have to draw HNO2. So this is the final thing. Okay. So what they have asked here, no? The In nitrous acid, the NO bonds are equal in length. Mono equal. This is a double bond, this is a single bond. It is mono, they are not equal. Puta, okay? 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 Hari. Now, if I ask a question like this, Puta, everything are you writing? Are you writing? Children, are you writing? Write everything very neatly. Eh? Hari. Now, Mihima, I am asking a question. Write a question under that, wherever you are writing this, write from a red pen. Is NO bond length in NO2 minus equal? Write that. Is NO bond length is NO bond length is NO bond length is NO bond length in NO2 minus is NO bond length in NO2 minus is equal. Is NO bond length in NO2 minus is equal. Is NO bond length in NO2 minus is equal. Answer? Yes or no? Answer is? Now you can see no NO2 minus. Is NO bond length in NO2 minus is equal? Answer is? Answer is? Online students, what do you say?
No.
Abhay, physical students are telling yes, Lu. They are equal. Ay, balang. Online people, what are you telling? Are they equal?
No.
Ah. You know what is the answer? Answer is they are equal. They are equal. Are equal. Double bond. Single bond. How come? No, the reason is now this is a iron. If they are ions, you can draw resonance structure. Putha, can you remember I taught you about a bond order? What is bond order for ions? Normally in ions we see a bond order. No? NO2 minus ion, CO3 2 minus ion, we see a bond order. No? I can draw two resonance structures like this. No? I can draw another resonance structure like this. No? So finally I can draw the resonance hybrid. No, these are resonance structures. Eh? Can you remember the resonance hybrid? How you draw what? How you to draw resonance hybrid? This is the way how to draw resonance hybrid. Resonance hybrid mean can see here. Can see no? Nitrogen and write all the permanent things. Whatever you can see on both, write every permanent things. What is permanent? Right. When you are doing resonance hybrid, you have to take the stable structures. Now, this is okay. Hmm. Good. Then, now see the minus charge here also minus, here also minus, both side minus. So this minus charge is distributed among how many oxygens? 2 oxygen. Then this also minus half, this also minus half. But can you see sometimes this double bond exists, sometimes this double bond exists. Here there is a single bond, sometimes here it becomes double bond. So this is between single bond and double bond. Therefore, what you have to put that? Dotted line. Again, this double bond is something like exist and doesn't exist. So this is a resonance hybrid. Therefore, what can you tell about now these two bonds length? This bond length, equal. Okay, because if you take the bond order for NO2 minus, NO2 minus bond order, if you take, okay, if you take the NO2 minus bond order, how to see the bond order? Can you remember bond order? How to see the bond order? Number of bonds, how many bonds are there? How many bonds are there? 1, 2, 3. 3 bonds are there total. Okay, number of bonds divided by number of places. How many NO bonds are there? 2. So 3 divided by 2 means bond order is 1.5. What does it mean by 1.5? This also 1.5, this also 1.5. Okay, the NO bond length is 1.5. Then what happened to HNO2? HNO2 එකේ පුතා now it's not a resonance structure no. Hydrogen is connecting for this. ඊට පස්සේ this becomes a single bond, this is a double bond only. ඊට පස්සේ they are not shifting their bonds or charges. ඊට පස්සේ this is a single bond, this is a double bond. ඊට පස්සේ කතාව different. No, ඒක පුළුවන්. ඒක මේ structure එක මේ structure එකක් නේ ඊට පස්සේ we will use. We can't change and roll like this no. Both the time. Got the point? Yeah, it means first of all if you draw the NO2 minus, if you draw the NO2 minus, this is a NO2 minus ion. But after fixing for HNO2, now if you try to draw this one in this way and this way, both are not going to be two different things, okay? මේ පැත්තේ ඉඳන් මේ පැත්තේ දැම්මයි දෙක එකයිනේ. No. These are not same. These are two different things. Because this oxygen is different, this oxygen is different. Okay, but if you draw the HNO2 in two ways, these are not two structures, these are the same structure. Got the point? Okay? That's the scenario. Therefore, HNO2's NO bond length is not same. It's a very nice thing actually. Okay. Again, NO2 minus is same කියන එක you should know. Then CO3 2 minus are the CO bond length same? In CO3 2 minus, are the CO bonds same? Answer is? Tell you. Answer is? Yes, yes. They are same. CO bond lengths are same. Why? These three bonds will distribute the 2 electrons among them. Therefore, CO bond length are same. If you take any anion, their bond length is same in the ion state. After they bonded with someone, their sizes can be different. Marmi important point ටිකක් ටක් ගාලා mark these things. After this part, they have asked the number of Lewis dot dash structures that can be drawn for the ion Cn2 2 minus is 3 yellow they have given. So more than these statements, they are doing something here. Are these things useful? Very useful. Okay. Online people, are these things useful for you? Have forgotten things? No?
Yes, sir.
Good. Now, the number of Lewis dot dash structures that can be drawn for the ion Cn2 2 minus is 3 කියලා they have asked. Cn2 2 minus second we have to see. Cn2 2 minus. This Cn2 2 minus. Are you carefully see this? But first of all, whenever you are going to draw Lewis structure or resonance structures for this, what should you do? First of all, you count the number of bonds because it's a second period one. If the second period is a central atom now, you have to do counting number of bonds. If it's third period or any other thing, you can do by taking the central atom connecting to valency. And you have to do this. So what is the carbon? Carbon is 4. Valency is 4. Nitrogen 3. Then 3 into 2 6. 2 minus now. Minus 2 now. What does it mean? I have to subtract 2 now. Minus 2 now. I have to subtract 2. Okay, I'm not adding 2. Minus 2 now. I have to subtract 2. 4 and 6 how much? 10 minus 2 8. So number of bonds will be how much? Number of bonds will be 4. First of all, I have to find how many bonds are here. Now we'll draw this. I have to draw carbon, nitrogen, nitrogen with, correct no? 4, 6, 10 minus 2, 8. Yeah. 4 bonds I am allowed to draw. First, I can put like this. Okay. You can see nitrogen's valency is 3. If it 2 now, this nitrogen will get a minus charge. This nitrogen will get a minus charge. Carbon is okay. So nitrogen get a minus charge mean normally how many electrons are around nitrogen? 5. 15th group no? Therefore, if I put a minus charge around nitrogen, there will be 6 electrons. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Clear? So this is Cn2 minus 1 structure. What can I do another structure? I can put triple bond for 1 nitrogen and single bond for 1 nitrogen and I can put 2 minus scalar. Then this is the other structure. What is the other structure? What is the other structure? Okay. Same thing. This side nitrogen like this. Side 1, 2 minus. But it can be stable or unstable, it doesn't matter. Nothing. Now these are the 3 structures. Can we draw any other structure for this using 4 bonds? You think can be drawn 3 කියන එක. What can you tell? Can draw 3 කියන එක? What can you tell about that? That is true. So these are the 3 things for C into 2 minus. Why? Right. Come fast. You want to buy a coffee? Okay. Right. Now what you have to do. Okay. Now we'll go for some other statement question in 25 paper. This year, the last year's paper. Whatever they ask in the last year. Now let's see what are the questions we can do in this 25 එක take. Right. In the 25 A level paper, you have these questions. It's in the group. You can check in the group. State whether the following statements are true or false on the dotted lines. Reasons are not required. Kilo, they have asked. The reasons are not required, but we are raising the reasons. Now, first one, second one, third one, fourth one, fifth one. Mm, sixth one, and this eighth one. Seventh one you can't do. No, no, seventh one also you can do. Seventh one. You can do all eight in 2025. Sorry. Try එකක් දෙන්න පුතා මේ 2025 these eight statements only. Huh? No, no need to write reason. You guys just write true false කියන එක පොඩ හිතලා කරන්න. නිකන් ඔහේ true false කියලා උඩ වලම් දාන්න නැතුව මේ 8 කරන්න. Do that. Okay. Now the next part. Okay. Now shall we discuss? Done? Done? Sixth one. Online students done?
Yes, sir.
Okay. Okay, we'll give you around 5 minutes. Tagala finish others. Okay. Now let's discuss. Now 25. The first question. The first question they have asked. Okay. The pairing of electrons in a particular subshell does not take place until all the orbitals of the subshell are singly occupied by electrons with parallel spins. What does it mean? Who said this? Very good. Hund's law. Now there are three people associated with electron filling. One is Hund. Other one is Aufbau. Other one is Pauli. Okay. So what did Aufbau only told the electron filling order 1s, after 1s 2s, after 2s 2p, after 2p 3s, after 3s 3p, after 3p after 3p after 3p. Who is after 3p? After 3p 4s, after 4s 3d, after 3d 4p, after 4p 5s, after 5s 4d. So it goes like that, right? So they will fill the electrons in that order. Right? Then the pairing of electrons in a particular subshell does not take place until all the orbitals of the subshell are singly occupied by electrons with parallel spin scalar. Who said? Hund. How Hund said? Hund said how they fill inside the orbitals. First electron will fill like this. Second electron in fill like this. Third electron fill like this. So all are having what type of this one? Same parallel spins. If it fill like this, is it correct? If it fill like this, mean if someone giving first of all electrons will fill in this order කියලා they are giving. Is it correct? Is it correct? Why? Because these are also having what? Parallel spins. If you draw like this, it what type of spin? Clockwise. This one anti-clockwise. First electron can it be anti-clockwise? Yes, can. Again, they can feel like this also. Because when you put this, they will rotate around whatever they want. So you can find this one in clockwise spin or anti-clockwise spin initially. Both are okay. Right? Then first statement is true according to Hund's rule. Alright, so you write that. Okay. It is true according to Hund's rule. Okay. Hund's rule. Everyone, whenever you are coming to the, definitely bring your smartphone. Okay. Don't mix that. Okay. Nowadays, everything is smart. No need to carry a big book. You can just carry a small bata. Hare. Next thing. The atomic orbitals identified by quantum numbers n and l. So they have given first one N4 L1 කියලා. පුතා for L can we tell subshell කියලා? Can we tell L is a subshell? What is L? L is a subshell. Ah. L is what? L is what? What is L, child? What is L? What is L? What is L? Can we tell L as a subshell? L is not a subshell. L is a orbital shape.
Shape.
Shape of the orbital. Don't tell subshell for L. L is what? Shape of the orbital. Now, if I put 0 again, what can it, now SQ, what? Is it a subshell? It's an orbital. But if I put with n, for an example, if I put 1 scalar, this is now subshell. N and L together only represents a subshell. Only L nang it's a orbital. Only N nang it is a energy level. N and L together, it will give you a what? Subshell. Okay. So they have given a few things here in the 25 paper. Okay, they have said first one, N4L1. What does it mean? N4L1 mang P, right? L0 mean S, no? First one is 4P. Second one, 4S. because N is for L is not. N3 L2 නම් 3D. Nice. එතකොට N3 L2 නම් ඒක 3D එච්චරයිනේ. Of increasing energy කියලා they have asked. Now out of this who is having more energy? Yeah. So it should come like this no. 4S 3D 4P. It should come like this no according to Hund's rule. Okay. So who should be the highest, right? Who should be the highest here? First one should be highest, right? First one only should be highest, right? ඊට පස්සේ who should be highest? Third one. ඊට පස්සේ who should be highest? Second one. The second one 4S only should be, it means 4S, it should come like this, no? 4S 3D 4P. No? The second, third one, so they have given third, second one. So therefore this become false. Nice questions. Yeah. So it is false. This one is false. Okay. Next one. They have asked the electron pair geometry of SOF4 molecule. SO4 F4 molecule කියලා they have asked. SOF4 molecule is square pyramidal කියලා they have asked. Right. Right. SOF4 mean? How can you draw SOF4? Again, SOF4 වලින් who should be the central atom? මේක බලගෙන. Who should be least electronegative? Sulfur, oxygen, fluorine? Sulfur. Pudha, remember the electronegative order. How to remember? Pone, කළොත්, බ්‍රෝට, ice cream දෙනවා, sisterට. This is the song. When sister eat ice cream, what will happen? She will get cold. Okay, remember this order. She will get cold. So FONCLBRISC. Okay. Now SOF4 mean how to draw this? Least negative is sulfur. So sulfur should be the central atom. So other people should fix to this sulfur with their valency. There are 4 fluorines now. 4 should fix like this. Oxygen should fix with a double bond. So 1, 2, 3, 4, 5, 6 all are okay. So make the shape. I think there are altogether 1, 2, 3, 4, 5 now. What is this shape? Trigonal bipyramid. Trigonal bipyramid, how actually they will fix? 3F will fix in this way. Other 2 will fix up and down like this. Again, this triangular shape and this up and down. Okay, this will get fixed. You think this is trigonal bipyramid කියන shape එක තමයි you will get from this. I think they have given square pyramidal. That is wrong. False. Draw the necessary things. So can you understand? Make these things you can answer now. These are the latest 2 questions. These are the last 2 papers. Now what are they giving in the first 5, first 7? Earlier they gave us to compare. Nowadays they are giving what? True, false statements. Okay, 24 and 25 both what they gave now? True or false statements. Okay. Now next one. So at least bang you have a chance to score even පොට්ට chance එකෙන් හරි 50-50 chance එකක් තියෙනවනේ if you don't know also. probability එකක් දෙන අර පොට්ටම කාල කන්නේක් නම් ඉතින් ඇවිල්ලා මේ පොට්ට chance වලින් ගන්න හැම එකක්ම if it get wrong ඉතින් ඒ කර්මම් තන් right. Now these are probability 50-50 no like in who wants to be a millionaire of this one එකේ අර 50-50 option එක ගත්තා වගේ තමයි true or false එච්චරයි. They didn't ask, no need to write the reason. 32 marks. 32 marks nang. How many marks in the final marks? 1.6. And 32 mean 1.6 will be added for your score. Not easy bang 1.6 can. It's a very good marks 1.6 can. Because for this structure they say everything only 50 marks. So you have to get 1 mark. You have to answer a big thing. අර මේ true false දාගෙන ගියාම නිකන් 1.6 එනවනේ බා. වාසිනේ ඉතින්. වාසිනේ? වාසි. Huh? If everything is correct, 1.6. For one question, 0.16. One question 0.16 නේ ඊට වඩා වැඩි නේ. 0.2. Okay. 8 questions නේ. 0.2. If one correctness, 0.2 will be added for your marks. Or a point hitang මාරම important in A level paper. That's a MCQ 1 නම් 1 කෙලින්ම. 1 correct නම් 1 mark. So MCQ is what a valuable paper. Structured essay also ටක් ගාලා you can score. හරි? දැන් හොඳට කරන්න. හරිද? Right. Don't get upset. අර මෙච්චර කරලත් 1.6ද? Yeah, 1.6. හරි. Next. The second ionization energy of lithium is less than that of beryllium. Yeah, second ionization energy of lithium is less than that of beryllium කියලා අහලා තියෙනවා. හරි. Second ionization energy, how can you see this? Same graph. Draw the same graph. Okay, now you have to see the lithium beryllium's area. No? So helium is here, lithium is here, beryllium is here. Now first ionization energy means helium is here, lithium is here, beryllium is here. When it comes for second ionization energy, what will happen? Lithium will go up here. Second ionization energy. Beryllium come here. Alright. Then the second ionization energy of lithium is less than of beryllium කියන එක false. Why? First ionization of lithium is low. Second ionization is very high than beryllium. Can understand? Alright. Write the necessary things. Therefore that also false. පුතා මේකේ බලන්න both the years 2024 එකයි 2025 එකයි. When you take most of the statements are true or false? No. 50-50 only they have given. Okay. Both the years bang 5 true statements, 5 false statements. Alright. Both the years they have given like that. 2024 and 2025 they have given 5 true statements, 5 false statements. 5 I'm sorry, 4 true statements, 4 false statements. So that is almost sorry. Not 8 ne, I heard like 5 නෙමෙයි. මේ එහෙම නෑ බං. Both the years they have given එහෙම පැටර්න් එකක් නෑ, නිකන් කටට එන එකක් දාලා දානවා ඒගොල්ලෝ රේ. හරි sorry ඉතින් එහෙම පැටර්න් එකක් නෑ to select. හරි බලන්න. ඊට පස්සේ next one, but you can score this no. It's අමාරු not difficult ones no. But I sleepy. Tired. For morning you had class. What's subject? Not chemistry. Ready? Right, okay. Alright, now say this one. Okay, shape go and write. Among the atoms, sorry, the electron gain energy of fluorine is a negative value. That is true. Who has positive value? Positive electron gain energy, whom? Positive electron gain energy for group 2, nitrogen, and group 18. Write that. Who has the positive electron gain energy? Positive electron gain energy is group 2, group 18, and nitrogen. Okay, they only have the positive electron gain energy. Other people, you know what is the electron gain energy? No? Okay, adding an electron for a gaseous atom. That is electron gain energy. Next one. What is next one? Among the atoms, beryllium, carbon, silicon, and sulfur, the atomic radii increase in the order carbon, beryllium, sulfur, silicon. All right, now let's see how the atomic radii increase. Now, beryllium is here, boron is here, carbon is here. ඊට පස්සේ sulfur, nitrogen, oxygen, sulfur is here. Then silicon is here. Okay, silicon is here. හරි. When you compare beryllium, boron, carbon, who is the biggest one? Beryllium is bigger than boron, boron is bigger than carbon. When you take carbon and silicon, who is big? The method they didn't give the boron, they have given beryllium and carbon. So carbon is less than beryllium. That is true. Carbon is less than beryllium. Beryllium is larger than carbon. Either they have given, when you take sulfur and silicon, who is larger? Silicon is larger. But sulfur is larger than beryllium. Sulfur is definitely larger than beryllium. So sulfur should come here. So carbon, beryllium. Huh? Yeah. I'm sorry. There is a thing like this. No? This silicon is larger out of everything. Okay, because here. But sulfur is smaller than silicon. Therefore, when you take beryllium and sulfur, who is the largest? Beryllium should be largest. Okay, because these people are large. Sulfur in this corner, the sulfur become small. ඉතින් මේක පොඩ්ඩක් අවුල් මේ question එක එච්චර අර fair නෑ because beryllium is somewhere, sulfur is somewhere. හරි. This I think what will happen? This is what you should do. Holes කියලා තමයි you have to go. Okay, increase in the order carbon, beryllium, sulfur, silicon කියන එක false. False. Okay. Because silicon is bigger than carbon but smaller than beryllium. Silicon නෙමෙයි, I'm sorry. Sulfur. Sorry? Okay, anyhow. Next one, seventh one. The boiling point of CH3NH2 is higher than that of CH3F. Okay. Why true? I think don't CH3F has hydrogen bonding? When you take CH3NH2, this one, this CH3NH2. This CH3NH2. Other one CH3F. Now from these people, this you have, this is the structure of this is the structure of this. Can CH3F molecule can make hydrogen bonds? Can't. Why can't? Why can't? What is the ruling of making hydrogen bonds? There should be a FON with a lone pair. Rule number 1. Rule number 2, there should be a hydrogen which is connected to FON. Both the things should be there. Now in this, we don't have a hydrogen connected to phone, but we have just fluorine. Fluorine with a lone pair is available. First condition is okay for this, but second condition not okay. So they confirm hydrogen bonds. When you come for this, first condition, hydrogen is connected to phone කියන එක, yes, me hydrogen is connected to nitrogen. Then okay. Second condition, there should be phone with a lone pair, nitrogen with a lone pair. දෙකම තියා, then therefore these people can make a hydrogen bond. Okay, therefore CH3NH2 boiling point is higher කියන එක true because they make hydrogen bonding. Okay, write the necessary things. Right, okay? Then the next one, right? Then they have asked the ionic radii of Al3 plus O2 minus F minus and S2 minus decreases in the order. S2 minus F minus O2 minus and Al3 plus decreases in the order. They have asked decreases in the order. What happens to S2 minus? Now when you take fluorine, fluorine is here, oxygen is here, sulfur is here, aluminum is here. So Al3 plus should be the smallest out of everything. That is sure. Because cation become very small when compared to anion. So Al3 plus is what a small. Nice. Then the other thing. Uh, O2 minus F minus S2 minus. Now more than oxygen, sulfur is big. No? Therefore S2 minus should be the largest. Then oxygen and fluorine, when you take, fluorine is smaller than oxygen, therefore O2 minus should be larger than that. Here F minus should be larger than that. Okay, S2 minus O2 minus F minus and Al3 plus කියලා තමයි okay යන්න ඕනේ. Yeah, because now from left to right radius decreases no, however. So O2 minus mean they are adding two electrons and they become very large because their electron pool get more. When they lose electron, they become very, very small. So this is the correct order of this. Yes. No, no, no. Although isoelectronic, their size is different. O2 minus is however oxygen is large and among from more than fluorine. So when they get one electron itself, they become the other size. But oxygen getting two electrons now. They become very large when compared to fluorine minus. Okay. Because when they add one electron itself, they become very large. මෙහෙම ඉන්න එක මෙහෙම වෙනවා වගේ. Right? Got the point? ඒ කියන්නේ ant is becoming like elephant වෙන්නේ නැහැ බං. ඒ ant elephant එච්චර ලොකු change එකක් නෙවෙයි. Something like cat is become dog වගේ. cat කියන්නේ small නේ. cat becomes අර ලොකු dog දඩ dog කෙනෙක් වෙනවා වගේ තමයි. It becomes right. හරි. So S2 minus F minus O2 minus and AL කියන 3 plus කියන ඒ option එකේ right ඒක false කියලා තමයි we have to take. This is false. That's false because this is the correct order. Can you understand? අර atomic radius එකේ order එක did we write? ඒක ලිව්වනේ අපි. Carbon, I said no, sulfur will come between beryllium and silicon is the largest. ඉතින් මේක පොඩ්ඩක් එච්චර fair නෑ ඉතින් අර හරි. I'm not taking this as a fair question. ලොකු fairness එකක් මේකේ නෑ. Right. Yeah. Okay. This okay. Now with this I will give a small break. ගිහිල්ලා ටක් ගාලා මේ pray කරගෙන එන්න. I will give you 15 minutes time. Okay, we have to finish at 6:30. No? So don't take much time. The people who wants to pray, go and pray. The people who wants to eat something, go and eat. The people who wants to do something, do and do. මොකක් කරගෙන ටක් ගාලා දුවගෙන එන්න. හොඳයි. May guys, do you got a red pen? Okay, children. So let's go for this question. Alright, now 24, we're gonna come again. We'll go for the Lewis dot dash structure for the molecule ISO 4 FK and will come. ISO 4F. So here F, here S, here O, here O, here I, here O, here O. But now these are belong to what normally the central atom key. Now we can take Hari. Now already 4 bonds are there for sulfur. So around sulfur you can form up to how many bonds? 6 bonds. Around iodine also you can form up to 7 bonds. So these are central people are group 3 people. Therefore connect these with these people with their equal to their valency. So oxygen you can put a double bond. This oxygen also you can put a double bond. No problem. 1, 2, 3, 4, 5, 6, 7. Then okay. This also you can connect with double bonds. Then don't forget the dots. Huh? Mostly you will forget the dots. If you forget the dots, it's a problem. Don't go to forget dots of anything. Huh? Don't forget, right? So this is the Lewis structure. Okay. Check whether it's correct. Correct. Did you draw this? No. Hurry. Then they have asked next question. Give the oxidation number of the sulfur and iodine atom. Sulfur and iodine atom. Because most of the people, they couldn't compare the sulfur and iodine's electronegativity. That's why I gave you this one. What? Phone, cloth, brought ice cream then our sister. Okay, so this is the word. Now with this, you can see the sulfur and iodine atoms oxidation number. Hurry, I'll show you. How you can check the oxidation number now? Now, Buddha, when you take fluorine and sulfur, who is more electronegative? Fluorine. Then fluorine get a -1, sulfur get a +1. This oxygen will get a, there are 2 bonds, no? Therefore this oxygen will get a -2, this sulfur get +2. This oxygen also will get -2, this sulfur get +2. Sulfur and iodine, who is more electronegative? Iodine. Therefore iodine will get a -1, sulfur will get a +1. Again, now count everything around sulfur. 2, 4, 5, 6. So sulfur you get +6 oxidation state. Got the point? Sulfur you will get a +6 oxidation state. And next thing, what is next? Iodine. So this is -1, mean this oxygen is -2, no? This is +2. This oxygen is -2, this is +2. So then this will get +2, +4, +3. This iodine will get a +3 oxidation state. This particular year in their A level, they gave 2 answers for this. The people who took sulfur as more electronegative than iodine, they got +5 oxidation state for this and +4 oxidation for state for this. They gave marks for this. Okay. Some people took sulfur and iodine both are same electronegative. Some people took. That also they accepted. Okay, sulfur then they won't have a +1 -1 in this one. Therefore they got a +5 here, however. Sorry, who took when they take sulfur as -1, they got a +4 oxidation state. If make a sulfur nothing they got a +5 oxidation state. When they make it, they got a +4 oxidation state. On the A they gave correct. I think that's because when you take the Pauling scale, iodine and sulfur having the same value. But take a හැමෝටම දන්නේ නැහැ. But normally when you compare චුට්ටක් iodine is චුට්ටක් more electronegative than sulfur. ඒක තමයි මේ කතාව තමයි real කතාව. I think they gave marks for everything. Sulfur +6, iodine +5 කියලා දැම්මත් they gave marks. Sulfur plus 6, iodine plus 3 කියලා ගමත් they gave marks. sulfur එකට plus 4 දාලා iodine එකට plus මොකද්ද මේ iodine එකට plus 3 දැම්මත් they gave marks. හරි. sorry. sulfur එකට plus 4 දාලා iodine එකට plus 5 දැම්මත් they gave marks. ඒ කියන්නේ oxidation state ගොඩකට they gave marks in this time because now we think you should know this. ඉතින් පව් කියලා බලලා තමයි marks ටික දුන්නේ. nice? clear? හරි. okay. ඊට පස්සේ next question. An acceptable stable Lewis dot dash structure for HNCO molecule is given below. Draw two more Lewis dot dash structures for this molecule and indicate their stabilities relative to the structure given by writing stable or less stable or unstable under these structures. They have asked you to write. When waiting, okay. Right. Then what should you do? When මේක තමයි this one. See double bond in and hydrogen and double bond O. Okay. So this is the first structure. So you have to draw another resonance. You can see how many bonds are here. 1, 2, 3, 4, 5 altogether. So using the same 5 bonds, you can draw another structure. HN. Between N and C, what can you do? You can put triple bond. And you can put a O and a minus. And you can put a plus here. What is the other thing you can do? Other thing you can do is HN. Now between C and O, you have to put a double bond, triple bond. Now see this, see this. Now C and O, you have to put a triple bond. Okay, you put a triple bond here. Now you have to put the triple bond here. Then this oxygen will get a plus charge. This nitrogen will get a minus charge. And this is the structure for this. But what should you say? This one is what? Less stable. Why less stable? Because more electronegative nitrogen having a plus charge. Okay, that is less stable. Methana, why this become what is this less stable or unstable? Unstable, right? Because plus charge is on the oxygen atom. Plus charge is on the oxygen atom. Plus charge is on the oxygen atom. Okay, that's why therefore we are taking this one as unstable. Next one. Next one is complete the table based on the Lewis dot dash structure and its label skeleton. All right. Okay, no? Ready, okay? Now, the number of VSCPR pairs around the atom. First of all, we'll draw the diagram. Here nitrogen, here hydrogen, here hydrogen. Here it's like this. Here nitrogen, here oxygen, and here nitrogen. Here nitrogen, here triple bond carbon. Okay. Then you get a minus charge here. You get a plus charge here. You get a plus charge here. And you got a double bond and a minus charge here. Okay. 2 electrons and a minus charge here. Okay, no? People, okay, okay. So they have named this one as 1, 2. We have a 3 gear name karla, we have 4 gear. They have named 4 nitrogen atoms here. First thing they have asked, the number of VSCPR pairs around the atom. N1, N2, N3, N4. N1 again, how many VSCPR pairs are there? First one is about VSCPR pairs. First one, how many VSCPR pairs are there? 1, 2, 3, 4. 1, 2, 3, 3 VSCPR pairs. Why? What are the VSCPR pairs? lone pairs and the sigma bonds. ඊට පස්සේ N2 එකට 1 2 3. හරි 1 2 3. Fourth one එකට 1 2. So only two VSEPR pairs are there. Second one, electron pair geometry. Putha, when we see the electron pair geometry, we can see the VSEPR and we can write the electron pair geometry. 4 na tetrahedral. 3 na trigonal planar. 3 na trigonal planar. 2 na linear. Shape around the atom. From tetrahedral, they have removed one. The shape is what? Pyramidal. This one, there are 3 sigma bonds. That is trigonal planar. This one, from trigonal planar, you have removed one, then it become angular. This one go with linear. However, 2 sigma bonds. Then they have asked the hybridization. The hybridization එකටත් පුතා මෙන්න මේ තුනම same answers actually. Using VSEPR only we write the hybridization. If VSEPR 4 නම් hybridization is what? sp3. Why? There should be 4 things joined together. 1s and 3p's altogether 4. Here 3 නම් there should be 3 things. 3 things 1s and 2p's. Here 1s and 2p's. Here VSEPR is 2 නම් 1s and 1p. Very simple. එච්චර මේ ටික fill කරගෙන යන්න තියෙනවා. පුතා for structured එක superior නේ. Can understand? Then they have asked parts 5 to 7 are based on the Lewis dot structure given in the part 4 above, labeling of the atoms. Identify the hybrid atoms orbitals involved in the sigma bonds. First, they have asked the between. They have asked between. Sorry, this hydrogen and N1. This hydrogen and this N1. They have asked what is this. So what is for hydrogen? For this hydrogen is just 1s. 1s atomic orbital. You have to say atomic orbital. By atomic orbital කියලා කියන්නේ or 1s na if it only one person නම් it's not a hybrid orbital. පුතලා observe here. 1s නම් what is that? Why atomic orbital? Because only one person. මෙයා නම් sp after that n1 කියන එක කෙනා. n1 means this sp3 කියලා already we did know. So sp3 what orbital then? Hybrid orbital. ඊට පස්සේ they have asked n1 and n2. So n1 is sp3 hybrid orbital. N2 is what? sp2 hybrid orbital. Then they have asked n2 and n3. N2 is sp2 hybrid orbital. N3 is what? sp2 hybrid orbital. ඊට පස්සේ n3 and n4. N3 is what? sp2 hybrid orbital. N4 is what? sp hybrid orbital. Okay. ඊට පස්සේ N4 and C they have asked. N4 is what? sp hybrid orbital, right? C is what? That also sp hybrid orbital. Okay. Then they have asked next one. When මේක තමයි මාරම important. Identify the atomic orbitals involved in the formation of pi bonds between the two atoms given below. Pi bonds. හරි මෙතන who are making pi bonds here? sp. Here sp. One sigma bond and one lone pair. sp. Hurry. Edagoda they have asked the pi bond. Now who are making pi bonds for that? Agala tell me. Out of these people, now who are making pi bonds? Yeah. This carbon is making pi bond. Between NC there is a pi bond. After that, between this N2 and N3 there is a pi bond. They make a pi bond here. They make a pi bond here. They can make 2 pi bonds there. Narni? That's fine. Then children, what should we do now? This now they have asked the pi bond. Puta now here who is making the pi bond? N2 and N3. Now you see N2 is made by sp2 hybridized orbital to sigma bond. Now normally you have 1s and 3p's like this. No 3p then d's come. No? Then s and 2p's are joined to make the sigma bond. And who will make the pi bond? P. What P? 2p. Second energy level P. Because nitrogen belongs to second level. No? Therefore, what should you write there? N2 and N3 na, both are N2 also 2p atomic orbital. Because atomic orbital no, will make N3 also what? 2p atomic orbital. Both are 2p atomic orbitals. Then N4 and C na? Between N4 and C, like how many pi bonds are there? How many pi bonds are there? 2 pi bonds. එතකොට this one 2 pi bonds mean N4 and carbon. Okay, both are first pi bond also 2p 2p, second pi bond also 2p 2p. Why? Because second energy level. Yeah, because it's second energy level. No? If it's a third energy level, no 3p. Nothing 3d. Sorry. For an example, we'll say you have a sulfur atom like this, some sulfur atom like this. Sorry, sulfur atom. What is the? We'll think like this. Okay, what is the hybridization of this sulfur? This is oxygen here. What is the hybridization of this sulfur? Here we'll think something like nitrogen here. What is the hybridization of this sulfur? Here hydrogen, here hydrogen. What is the hybridization of sulfur? sp2 3. sp3 ne? Then which one this sulfur is making the pi bond? Now pi bond is made up of this sulfur and oxygen. Which one? Now sulfur sp3, this oxygen is sp2. Okay, sigma bonding, this one is sp2 hybridization. Now sp3 S and 3p's are joined to make the sigma bond. Then who will make the pi bond of this sulfur? D. Which D? 3d. Either a pi bond is made by 3d of sulfur. Here oxygen is sp2 ne. එතකොට other one is 2p. Always it is not 2p. Depending on the person. එතන සල්ෆර් වගේ එක්කෙනෙක් කෙනකොට 3D කියලා එකකුත් can expect. ඒක ඔය හොඳට ලියලා තියාගන්න. And understand? Okay, so the pi bonds seen is like that. I hope it is clear. Write all the necessary things. Next one. The next question they have asked. State approximate bond angles of N1, N2, N3 and N4. They asked to approximate bond angles of N1, N2, N3, N4. All right. Now N1, N2, N3, N4 approximate bond angles. No, they have asked. How can you see the approximate bond angles of N1, N2, N3, N4? N1 mean what is this tetrahedral? Tetrahedral 109 degrees. From that, if you remove 2 electrons, it becomes 107 degrees again. N2 nang kohoma trigonal planar, so 120 degrees trigonal planar. This angular is so trigonal planar mean 120, 120 you have to reduce 2. Then N3 will be 118 degrees. The method between NC, yeah, මෙතන N4 කියන එක 180 degrees. ඉතින් ඒක 180. ඉතින් ඔච්චරයි. නේ ලොකු සීන් එකක් නැහැ. Got the point? Can understand, children? Alright, next one they have asked to arrange these atoms in increasing order of their electronegativities. Now, when you want to compare the same atom only, you have to check those 4 things. Now, when you want to compare all a nitrogen, when you have nitrogen and carbon, if they ask to compare, who is more electronegative? This nitrogen or this carbon? Who is more electronegative? This nitrogen or this carbon? Huh? Nitrogen. අඩේ ෆොන් නේ බං. ෆෝන් කළොත් අදාළ නැහැ. අදාළ නැහැ අපිට. This nitrogen or this carbon more electronegative? This nitrogen. Then this nitrogen or this carbon? Nitrogen. මොන nitrogen හිටියත් ඌ තමයි ලොකු. This nitrogen or this oxygen? Oxygen there. Okay. හරි. Got the point? It is a nitrogen නම් ඌ nitrogen වැඩි. ඌ මොන nitrogen වුණත් ඌ තමයි ලොකු එක. in the electronegativity. The electronegativity, nitrogen only the highest. Nitrogen and nitrogen only, now we are going to compare now. Here, when we want to compare the same nitrogen people, we have to see four things in order. What are the four things in order? H we have to see. HCOA. HECOA. What? HECOA. 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 So HECOA කියලා you remember වක්කරිය. ඒ වර්ඩ් එකක් එන්නේ right? Okay. දැන් ඒ මෙතන තිබ්බන හාකෝ කියලාවත් කියන්න තිබ්බ right? ඒක වල්ලයානේ බා right? නැත්නම් අර කෙල්ලෙක් පල්ලෙහෙන් ඉඳන් කෑ ගහනවා වගේ you can tell. Ouch ගාලා. Right. You can say ouch. But you have to tell from down, down to up. කෙල්ල අර පල්ලෙහෙන් ඉඳන් තමයි කෑ ගහන්නේ. Ouch ගාලා right? වක්කර remember ඉතින්. ouch. හරි. අර ouch කියන්නේ ගොඩක් කෙල්ලෝ දන්නවනේ. කොල්ලෝ කියනවා ouch කියලා. අර when they get a pain, ouch ගන්න. Have you heard girls telling ouch? No. Normally posh girls they say. They don't say ආයි ගන්න. අර නිකන් අර ගමේ කෙල්ලෙක් වගේ right? ආයි අපෝ ගන්න right? මොකද්ද ගන්නෙ? ouch ගන්නවා right? ouch. ඒකත් posh විදිහට තමයි ouch එක ගන්නෙ right? ඊට පස්සේ ouch තමයි. හරි? හරි. ඊට පස්සේ H mean what? Hybridization. C for charge. ඊට පස්සේ oxidation state. ඊට පස්සේ attachment. හරිද? So what is hybridization here? Hybridization means when more S character, electronegativity is more. It means when S character is more, S character is more, P character should be less. So we got the hybridization here what? sp3, sp2, sp2, sp no. එතකොට definitely N4 only highest electronegative atom. Why? Sp ne? The more S character, less P. Less P nang it is more N4 is the first. Then N3. Now N3 and N2 both are same hybridization. එතකොට but N4 is highest, N1 should be the least කියලා we know. N4 should be the highest oxidation state, N1 should be the least. Now I don't know about N2 or N3. Now hybridization gone. ඊට පස්සේ we have to go for the charge. Charge එක this has a plus charge, this is a neutral. Sorry, yeah, this is plus charge, this is neutral. එතකොට plus charge and neutral නම් who should be more electronegative? Neutral or plus charge? No. Plus charge person or more electronegative? Electronegative mean what? Ability to attract the electron. When it's neutral atom, they can easily attract the electron. When they have a plus charge, they can easily attract the electron. When they have plus charge, electrons will come. අනේ යාට plus එකක් තියෙනවා කියලා දුවනවා right? Therefore, when they have plus charge, they will attract more towards the electron. Oxidation state එක ගැන කිව්වොත් more oxidation attract the electron, less oxidation attract the electron. Huh? More oxidation state නම් they love electron. More oxidation state නම් ඒ කියන්නේ a person is plus 5 oxidation state උට electron ආසයි. Attachment නම් after these things all these are same now finally only we are going for attachment. Attachment එකේ බලන්නේ if more electronegative element is attached now their electronegativity is more. Okay. ඉතින් එහෙම තමයි we have to check. එතකොට out of this we can tell N2 is more than N3 කියලා we can come to a conclusion. හරි. ඉතින් ඕක තමයි යන්නේ but they have given in the other way no. අද වේ කියන්නේ ලොකු එක අර පැත්තට තමයි they have put. කියන්නේ N1 N3 N2 N4 කියලා order එක තමයි ඒක යන්නේ. පුතා ඉතින් මෙතන you can score the full marks තියෙනවා. හරි. ඊට පස්සේ they have asked arrange the following species in the increasing order of the property indicated in the parenthesis කියලා they have given boron, oxygen, fluorine, sulfur, sodium, magnesium according to their electronegativity. According to the electronegativity කියලා they have asked. හරි ඔඩක්. So this session is කොච්චරක් worth it? Worth it a lot. එතන අමාරුවෙන් ඕගොල්ලෝ ආපේකට you learn a lot no? Right. Because with the papers only bang you can learn more. Hare? I don't know what this Vasil man doing. Hare? No. When you're in this class, always you will feel like raining. That's this class vibe. Hare. Now, Buddha, When you take boron, oxygen, fluorine, sulfur, sodium, magnesium, right? When you have these things, now you know sodium, magnesium is like this, neighbor. Boron is here, boron here, sodium is here, magnesium is here. ඊට පස්සේ මේ sulfur is here, oxygen is here, fluorine is here. So fluorine one ඉතින් 4 තමයි F තමයි highest, then no, then sulfur. මේ order ටික we know. Now out of boron, magnesium, sodium, definitely boron is highest, then magnesium, then sodium. This is the order, very easy. Other one ionic radius they ask us to compare K plus Mg2 plus Ca2 plus Al3 plus Cl minus S2 minus කියලා they have asked to compare the ionic radius. ඉතින් මෙතන cations are small, anions are large. Cations are small, anions are large. Cations එකේ who is very small? Whoever releasing lots of electron, they are very small. So aluminium 3 plus is the smallest. ඊට පස්සේ we have the cations called K plus magnesium 2 plus calcium 2 plus. එතකොට out of this K plus is the largest out of the cations. Now observe here. Out of the cations, aluminium should be the smallest, K plus should be the largest. Now magnesium and calcium they are no. Calcium is bigger than magnesium no. And the calcium 2 plus is bigger than magnesium 2 plus. That is. Now from the anions who is larger? Cl minus or S2 minus? Across the period radius reduces, yeah. But the negative charge is, remember like this if you don't know. No, careful listen. Here lithium no. Here fluorine no. Here sodium no. When F is gain an electron, it become F minus no. When sodium release a electron, sodium plus no. When F minus get an electron, when sodium lose an electron, sodium plus will be smaller than F minus. Again, the smallest anion in a period is larger than the largest cation in the next period. Sodium plus is the largest cation in this period. Magnesium 2 plus aluminium ion take a podium. Then smallest anion is F minus. No? O2 minus is larger than F minus. N3 minus is larger than it is the smallest anion is F minus. So smallest anion itself larger than the next period's cation. Got the point? Okay, ඒක මාර ඒක හොඳටම ඔළුවේ දාගන්න. Okay, ඒක පොඩ්ඩක් ඕන්න ලියලම තියාගන්න. So it will be helpful to you. එතකොට Cl minus S2 minus කියන එක you can put, then S2 Cl minus is here, S2 minus is here. Okay, sulfur chlorine නම් sulfur is larger than chlorine, so S2 minus is larger than Cl minus. මෙන්න මේ points ටික clearද? Are these things clear? Then 24 paper එකේ first structured එකයි 25 එකේ structured එක තමයි we were discussing. හරි. ඊට පස්සේ they have asked draw the most acceptable Lewis dot come for 25 now. 24 ටික ඕකේනේ. ඕන මොකක් හරි තියෙනවා නම් mark කරගන්න. I will give you 2 minutes, 2-3 minutes. මොකක් හරි තියෙනවා පොඩි try එකක් දාන්න 25 එකේ Lewis structure එකට. Give a try. Try for the Lewis structure. මෙන්න මේ පොඩි try එකක් දාන්න Lewis structure එක විතරක් අපි try එකක් දාගෙන යමු. මෙන්න මේ first B එකේ first and second විතරක් කරන් ටක් ගාලා. Okay. Now you have to draw the most acceptable Lewis structure for the molecule ClSO2F. Right. Now you have a, now we did know so many questions related to this now to today itself. ClSO2F. ClSO2F means children. Who should be the central atom? Least negative is sulfur. So sulfur put the central. Then connect other people with equivalent to their valency. Two oxygens now. Connect two oxygens like this. 1, 2, 3, 4, 5, 6. I think very okay. Very simple. And they have asked what is the oxidation state here? What is the oxidation state of sulfur? So you know all are more electronegative than sulfur. Inside because of this get a plus 2, because of oxygen this get a plus 2, because of fluorine this get a plus 1, because of chlorine this get a plus 1. Altogether sulfur's oxidation state will be plus 6. What a lazy ready? Now did you get a confidence? The main okay A level question okay. Right? Mainly then give the oxidation state of sulfur. Sorry. Then we're taking a P. Now I got third one. A stable Lewis dot dash structure for the HN2 O2 minus ion is given below. Draw two more Lewis dot dash structures for this ion. Indicate the stability of the each of the structure drawn by you relative to the structure given by writing stable, unstable, or less stable under the structure they have given. හරි. එහෙනම් අපිට අග්ගාලේ ඒ වැඩෙත් බලාගෙන යමු. හරි third question එක. See the third question. Now here H nitrogen and double bond nitrogen, there is a plus, right? There is a plus charge, and here there is a O minus, and here there is a O minus. Okay, so O minus there, and here there is a plus. I think already got the we have built up this. I think they have asked two more structures for this. No? If you want two more structures for this, okay, two more structures for this. H N N. Hurry. You can't change the number of bonds. May bonds for the 1, 2, 3, 4, 5. There are 5 bonds. No, there 5 bonds you have to put. What can you put? You can put a double bond oxygen and you can put oxygen here. So this oxygen will get a minus. Okay, this oxygen will get a minus. This will get what? These two bonds. And so this also will get a minus. This nitrogen will get a plus. So this is one structure for this. If you want another structure for this, they have asked to draw only two more structures. So I think lazy never same thing draw. Just change the flip the bonds here. I think what can you tell about this? Make unstable, the less stable, the go. This will be what? Unstable, the less stable, the this will be less stable, right? Why you are telling less stable? Because however oxygen having the negative charge. Oxygen have negative charge when compared to this oxygen, this nitrogen is more electro more electronegative person. They are muge pass එකක් තිබ්බ කියලා අවුලක් නැහැ ඒක. And next adjacent also having plus and minus charges නේ නිසා එච්චර unstable ගතියක් නැහැ. Less stable කියන ගතියක් තමයි these people are having. Less stable කියන එක තමයි answer එක. හරිද? වැඩි ගෝකිනේ. Then හොඳයි. ඊට පස්සේ they have given the fourth one. Complete the table based on the Lewis dot dash structure and its table skeleton below කියලා. They have asked so many things related to that. They have given F N N N. Here also so many n's, no? N N N N. 4 n's are here. It was a method they have connected the hydrogen. Hurry, and here there is a double bond, and yeah, two double bonds next to next, and you get a plus here. Hurry, and you get a minus here. Again, they have asked the things. Hurry. Right. Now they have asked first one. n1 n2 n3 n4 කියලා they have given these things. They have given 1 2 3 4 කියලා numbers ටිකක් they have given for this. The first one they have asked what is the number of VSCPR units. Number of VSCPR units mean n1 එකේ you can see 1 2 3, n2 එකේ you can see 2, මේකේ you can see 2, n4 එකේ you can see sorry n3 එකේ 3, n4 එකේ 1 2 3 4. හරි. The electron pair geometry 3 නම් you know trigonal planar, linear, trigonal planar, tetrahedral. Shape around the atom, this one is what? Angular, linear, angular, angular. නැත්නම් bend shape කියලාත් you can write. ඊට පස්සේ fourth one hybridization of the atom. ඉතින් මේක sp2 sp sp2 sp3. ඉතින් ඔය වගේ චුට්ටි කැලි ටිකක් තමයි උතන තියෙන්නේ. So can understandable? හරි වැඩේ ඉවරයි ඉතින්. ඊට පස්සේ ඉතින් මේ angle ටිකක් අහලා තියෙනවා. ඕක ඇති. අපි වැඩේ මෙතනින් finish කරගමු. අනිත් ටිකත් ඕකේන everything ඕකේන. හරි. දැන් මේ කතාව නෝ ඕකේ. හරි. So next time please come on time. Next day please come on time. අපි 3:30 වැඩේ පටන් ගන්න ලස්සනට අපි කරමු. මේ මාරම worth it නේ වැඩේ. හරි next week එකේ තව වැඩ ටිකක් කරගමු. එහෙනම් අස්සලාමු අලයිකුම්. And okay, good evening. That's all.